Okay, some more problems from section 9.1. I kind of want to emphasize this. I should have written this down for you. Just to emphasize the fact that if we go back and look at 21, we've already done these, but just quickly, if you can make sure you write these down. So this emphasizes the fact this is actually our interval of convergence. This is our interval of convergence. Okay, these are the values for which x converges, but that's the interval of convergence. Again, on 22, this was the interval of convergence. It's actually an open interval. And on 23, this was an interval of convergence over here. So try to kind of notate that, write that down so you see that. That's an important concept, and I probably should have stressed that a little bit more. Okay, let's take a look at number 24. And again, the same directions, 21, 22, 23, 24. Find the interval of convergence and the function represented by the geometric series. So this was our given series, the summation n equals 0 to infinity of 3 times x minus 1 over 2 to the n power. And I could write these out. When n is 0, I've got 3. When n is 1, I've got 3 times the x minus 1 over 2. When n is 2, I've got another multiple of that. So I think you can see that you just keep taking 3, multiply by one of these, and multiply by this again. You get that, multiply by that again, you would get the next term. So 3 is my a sub 1, or my first term, and r is x minus 1 over 2. So again, that's going to be a convergent series as long as r is, the absolute value of r is less than 1. So again, I can just put this absolute value, change it to less than 1 greater than negative 1, multiply through by 2, add 1, and this is what I get. So this is my interval of convergence, negative 1 to 3. All right? And again, the function over this interval of convergence for these values of x on this interval of convergence will equal this sum. And again, S equals, in our case, a sub 1 over 1 minus r. Okay, that's what we've got. So a is 3, 1 minus r. And this case, this one I just kind of did our shortcut way. I multiply the top and the bottom by the LCD. What's the LCD? That's 2. So I just multiply the top and the bottom by 2. Times 2 times 2. Which is the easier way to approach. 2 times 3 is 6. And then 2 times 1 is 2. And these 2's cancel. So I've got negative x plus 1. Alright, and then a 1 plus 2 is 3, so 3 minus x in the bottom, 6 in the top. For these values of x, this is my function. Okay, number 25. Okay, and again we have this summation. We've got the sine to the nth of x, so I rewrote it as sine of x to the nth power. So when n is 0, I've got 1. When n is 1, I've got sine squared, etc. Okay? So now we have a sub 1 is 1. Alright? And then r equals the sine of x. So when is this going to be less than or equal to 1? Alright? Well, it's going to be less than or equal to 1. You know, we know that the sine of x, oscillates between positive 1 and negative 1, although it can be positive 1 or negative 1, and then it's not going to be convergent. So it's at any value except where the sine is 1 or negative 1. Remember, the sine goes from 1 to negative 1, so it does have those values. So wherever it's 1 or negative 1, we can't have that. So on my interval of convergence, it's in between here, so it's on this open interval, negative 1 to 1. But that's for sine of x, not x. That's the problem. Okay? That's for sine of x. So what am I going to do for x? Well, I can say x does not equal 2k minus 1 times pi over 2, and k is an integer. And if you do that, that's going to eliminate all these. In other words, you can see if I've got 2k minus 1, if k is an integer, like let's say k is 0, 2 times 0 is 0, minus 1 is negative pi over 2, negative pi over 2, I've got 1. Alright, and if k is 1, 2 times 1 is 2, minus 1 is 1, so that's pi over 2. So this generates pi over 2's and multiples of pi over 2. All right. That's when k is 1. When k is 2, that's 4 minus 1. That's 3 pi over 2. Here we go. So that just eliminates these. So this is a little technique to do that. So that's how I'm going to actually kind of get my values for which it converges. And number 25, the directions were a little bit different. So they didn't ask you for the interval of convergence because this is not going to work. This is the interval of convergence, and I should notate that this is for sine of x. Okay, this is the interval of convergence for the sine of x. But we want x, so we have some issues there. So the interval of convergence for the sine of x would be in here. What makes the sine of x in this interval? All values of x except for these. So these are actually the values of x for which it converges. And that's why they gave you the directions on number 25 and 26. Find the values of x for which the geometric series converges, and then find the function of x it represents. And again, we have my a, or my a sub 1, we have our r, so we have 1 over 1 minus r, and that's your function, and not much we could do with that. All right, so it's a little tricky, but again, we don't have to find actually the interval of convergence, we just have to find the values of x, and these are the values of x. All values of x except, so we can just say x cannot equal these particular values, and those will give me the values of 1 or negative 1. So that was a little tricky to come up with those values. Take a look at that. I hope that makes sense. I kind of wrote it over here, kind of how I figured that out, so you can kind of see how this works out here. And then number 26, the last one. Again, find the values of x for which the geometric series converges. And actually, this is incorrect for me to write the interval convergence. It kind of gives you that, but these are just the values of x, so kind of cross that out. Sorry about that. Okay, and let's take a look at this. So this is the tangent on number 26. And the tangent equals, my function was the summation n equals 0 to infinity of tangent to the nth power, so I could just make that tan of x to the n. So when n is 0, I've got 1, tangent of x, tangent square of x, so I think it's obvious that a sub 1 is 1, and my ratio is the tangent of x. So whenever the tangent of x is, the absolute value of the tangent of x is less than 1, I'm in business, so that I want the tangent of x to be between negative 1 and 1. So I kind of graphed my tangent of x so you can see what's going on here. And remember, the tangent of pi over 4 is 1, so it's got to be in these little intervals. And the fact is that since it's periodic, it creates some issues. All right? And I kind of was working with my unit circle over here, my values, to see what's going on. And I came up with the fact that whenever x is between negative pi over 4 plus k pi and pi over 4 plus k pi, where k is some integer again. K is an integer. K belongs to I. Probably should have written that down. And that's going to make the tangent between negative 1 and 1. So like, let's say k is 0. If I have 0, if x is between negative pi over 4 and pi over 4, so here's like negative pi over 4 and pi over 4. If x is between that, not equal to that, open, then you can see how this is 1 and this is 1. You can see how the tangent's in here, and that's what I want. I should maybe just highlight those. Those are the values I want, and then here's another one. And then here's another one. Okay, so these are the values, so like between negative 5 pi over 4 and 3 pi over 4. The tangent is going to be between, and this would be, I should put 1 over here, this is 1. And negative 1. This is 1 and negative 1. And again, this is 1 and negative 1. So these are tough to figure out, but as long as the tangent, as long as x is between these values, the tangent of x is between -1 and 1, and that's what I want for the series to converge. Okay, so converges for those values. So again, it's I use my same sum formula, S equals 1 over 1 minus R. So that's easy. This was the hard part, figuring out the values for which it converges. So as long as x is between those, and k can go from any integer, 1, 0, 1, 2, or -1, -2. So hopefully that'll work. That's a tough one. Those are tough ones to figure out. Okay, I hope those help.